Welcome. We are going to use the HPC to launch a QIIME Data 2 job. So we have instructions on our lab notebook page for the QIIME and Data 2 activities. And we're going to start with a tutorial that Dr. Lisa Lowe created for us called QIIME2 tutorial. And it's open over here. We'll first start with the submit analysis document over here. And we'll begin by using MOBA Xterm, and I am going to start a connection to login.hpc.ncsu. So I log in, and I have my prompt, and I'm going to see what's in my directory. As you can see, I'm logged into login 03, and I'm going to begin by doing a change directory cd to the shared directory BIT577 fall 19. I'm going to do an ls to list the directory content, and you can see we have several folders in blue. Those are the folders that were created by users, and you can see some usernames. We have a GG13 8 classifier QZA file, and these are the 16S databases. One of these, the smaller one, is the one used in the Moving Pictures tutorial, and then we downloaded the bigger database from Green Genes. One comment is you may consider using Silva. Silva is another database that's updated more frequently than Green Genes. So the next step here in our tutorial is to make a directory mkdir with my username ccgoller, and I'm going to check that that directory is made, and you can see that it's created there. I'm then going to change directory to my directory, and I can use the $user to change to that directory. And you can see now I'm inside that ccgoller directory. Within that directory, I'm going to make the mkdir run directory. So create a run directory and a tutorial directory. So right now we can see that we created a run directory. Let's create a tutorial directory. And now you can see both of those. And we're going to cd change directory to run. So right now I'm in the run directory that doesn't have anything. So my next step is to copy the script to my run directory. And if I back out a little and go to the main class website, you'll notice that we have submit.csh, submit full _full, and a submit rest. So Megan Boland and I have been testing out some longer scripts that have some of the analysis that are performed later on in the Moving Pictures tutorial. So keep this in mind. Okay, I'm going to go back to my directory, to the run. Now that I'm in run, I am going to copy the submit full.csh file or period, so that the copy set up. I made a typo there, sub. So that should be correct. And let's check that it copied, and it did. So now let's take a look at the contents of that script with the less command. So less, in my case, it's submit _full.csh. So this shows us what's going on in this script. So as we talked about in class, here are some of the parameters for shared memory, the name of the job. Um, we set this number of cores. Here's where we can modify some of the parameters. So left truncation, left trimming, and this is dependent on your sequence quality. This is where we set the environment. So this we did for you, but we have a folder called data within our BIT577 Fall19 folder, and these are the .gz fastq files that we uploaded. And our mapping file is also located in the data folder, my_mapping.tsv. So if you wanted to run these at QIIME data 2 job with your own data, you would have to create your folder and add your fastq files and your mapping file. So the next part is importing the sequences, paired end sequences with QIIME. And QIIME is going to create an output file, paired end.qza. So next we start creating a demultiplexing and summarizing. And this step down here is the data 2 step. So this is where it's going to feed in those trimming and truncation values that are dependent on your sequence quality. So one thing I suggest, maybe run it with default values the first time, analyze your data set, then change these parameters. So the data 2 denoising step, as we talked about, will create this repseqs data 2 QZA file. And then we can start tabulating the meta data using that file we created previously, creating some visuals. And remember, those QZVs are visual files, and we can open all these with the QIIME view. So the next couple of steps are using data 2. Data 2 produced representative sequences, and the goal is to get a table of representative sequences. But then we start doing some of the phylogeny. So here we start aligning to a tree using the mapping file that we provided. We'll import that tree we created in the previous step. So remember, I is for inputs, O is for outputs, M is for metadata, or the map file. Notice that it's called map file here so that we can change it just once at the beginning of this script. But here is where we'll start creating those alpha and alpha diversity summaries, looking for significance. And this depends on your mapping file and how you set up the groups, how you set up the different treatment groups. One thing I want to highlight is the classifier file that we're using. You have to tell it which database you're going to use and where that database file is located. So here we're using this one. You could use Silva, for example, and this will, as we noticed in class, depending on whether you use the file provided in the Moving Pictures tutorial or the full Green Genes database, the latest update, that will really influence how many of the sequence you can classify. Okay, so this is the script file. So down here, we can modify this script by altering the trim left and trunk length, so the trimming and truncation length, and that we can do by looking at some of the looking at the script and changing it. Or Q to return. We did not modify the script, so now to if we wanted, we could modify that script depending on our settings and our what we want to do. But now let's submit the job to LSF. So for that, we can do b sub, and we're going to submit full.csh, which was the script we were looking at, and hit enter. So then it says job 992127 is submitted to Q shared memory. So if we wanted to see what jobs have been submitted, we could do BJOBS, and it tells us that this job that has the same ID, the job I just submitted, has with the job name QIIME2 was submitted at this time. And if you do list directory contents, you can see that we now created the standard error and standard out. We have our script file, submit underscore full.csh file, and our log file. So we can return later, and once the job is finished, we can do this last part of the tutorial, which basically is going to the run directory, and I'm currently in the run directory, seeing your files, listing the files with, in this case, LRTH, to look at the file size and some of the read, write, execute privileges for those files. Right now I don't have too many files because I just submitted the job. But what we would do, we would create a directory called, in my case, CC Goller, username and -viz. We would copy all the QZV files. These are all the viz files, all the graphs that QIIME2 creates. We would also copy all the core metrics results. So QIIME2 creates a core metrics results folder with several QZA and QZV files. We'll copy the QZV files over. And what we're going to do with this tar command is we're going to zip them together or compress them together so that we can download this file. So to download a file, we would open another terminal. For example, open another one. And we would run the scp command, give it the directory, and everything that's highlighted in yellow with Unity ID would be your username. And we would copy, we would tell it, go to this directory, my username, find the tar file we just created, and copy it to my local machine. And then we can use QIIME to open those files. Okay? Happy exploring QIIME. Give this a test, try it out, change the parameters, and look at your results. Good luck.